Hey guys, how's it going? In this video, I would like to come back to this problem, Leetcode 140, word break number 2, to improve a little bit on the solution that I had before, because this was very popular lately. That's why, because we might get asked by the interviewer how to optimize a solution. Originally, I had the solution on the recursive function. Now I want to put some dynamic programming on top of it, so to improve some efficiency. So this is what I had before, and now let's work together and let's improve to make it dynamic. So for dynamic programming, we need a memorization variable, which I'm gonna use it as a dictionary. So I'm gonna call it memo, and for the memo, the key will be the substring, and the value is all the possible eligible sentences. Okay. So this is the key variable that I'm declaring right over here. And I do not need the result set anymore because I'm going to rely on the dictionary, and there will be quite a bit of change of the recursor. I'm going to rewrite the whole thing, and I don't need the list anymore. So first thing, if we are given a string, a substring, if that is empty string, right? It looks like this. If we given something like this, we are done, right? So this is a terminal condition. So I'm going to return a keyword as a word and to signify that we are done with it. So that means I'm going to put some comment in here. That means we have already have a complete sentence in here. I'm going to show you how I use this keyword and in the later implementation. And also, same as before, if the length of the given string is less than the minimum possible length of all the word in the dictionary. So for example, the minimum length in here will be 3, right? Because it's the shortest word in dictionary. And if that's the case, I'm going to return a none. And if we can find the eligible sentences in the dictionary, and then we just directly look up in the dictionary, right? So we don't have to do the rest. So this is where we can save a lot of time. And by the way, and this is how we can use the memorization method. I'm gonna walk through in this good diagram in here. Looks really good to me. So for example, we are given a string of a cats and doggo, and we break it up by in this part, like send doggo, also end doggo, and both of them has the subphrase of a doggo, so we don't repeat our work. This is how we can save the intermediate step with in the memorization dictionary. And that's exactly what what we are doing in here. And I need a temp set to keep track of all the potential eligible sentences. So for word length, in the length words map, if we found the word in the dictionary, what we're going to do, we just assign it. We first assign it to a temp string, and then we will recursively call the rest. So I'm going to call it faces, and then I put it back to the recursor of the rest of the given string. Because for the first part, we already found in the dictionary, right? Before this is the first part, so we gotta throw the rest back to the recursor to let it analyze the rest. And if what comes back, and this is where we use the end keyword, right? If the what comes back is the end keyword, that means we are done. So we have a complete sentence in here. So we just append that, well, not append, to add it to the temp set. The reason why I'm using a set instead of a list in here, which connects with here, here it says in here with the values possible sentences, but here I'm declaring a set because I don't want any duplication. That's why I put it in set in here. And at the end, I'm going to convert it back to the list. And else if, so means that right now we are looking at not a and keyword. So else if there is something in the phrases, meaning that what comes back is not none. But none means it's impossible that we will have a complete sentence. It's kind of broken, so that's why we return a none. And if not a none, so it's not an and keyword, also it's not a none, that means there's something comes back. And there will be multiple phrases comes back. So for each of the phrase, and then we add them to the temp set that we declared earlier, right? So basically we concatenate the temp string that we assign. So basically this is the first part that we found in dictionary in the word dictionary over here. Oops, come back in the word dictionary over here for the first part, and then concatenate to what comes back. So essentially what's going on here was I'm gonna print off the memo dictionary later on, so you know exactly what I'm doing. And at the end, don't forget to put it back to the dictionary and then convert to a list, because how I did declare it. And also I gotta return the result. And then I don't need this one anymore. But what I do need is to return the result and then call the recursor on our string. And let's run that. And it works. I'm going to show you what is inside that memo dictionary by printing off here. And also put the string inside as well, so you can see them in a pair. Okay. So as you can see, for example, this is the dictionary. This is the memo dictionary. Dog is, so that dog is the key. Value is the dog. Send dog, as you can see, it comes back as a list. And send dog will be send space dog. Okay. And dog will be n space dog. Cats and dog, or you can pronounce it as cats and dog, will have two complete sentences. One is cats space and dog, or cat space sand space dog. Okay, so this is exactly what's going on in this memo dictionary, and this is how we can avoid some repeated work. So let's run that, submit the solution, and it works. It's way more efficient than what we had before. And yeah, so this is my second try this problem, because there is high chance that we might get asked in an interview where if we use recursion, and then the interviewer might ask us to how to improve it. And one common approach to improve a recursion method will be use a dynamic programming. So this is why I want to come back here. Thank you so much for watching. I hope this is helpful, and if it is, please like and subscribe. That will be a huge support. Thank you so much once again. I will see you in the next video.